Thank you.
Just hello?
Thank you.
This is a quick update to Jeff's speaker notes. He's graduated from lumberjack to trucker.
Yeah.
He has a shirt now that measures the beard.
This is Roddy Haddad. I'm Jeff Cross.
And I'm Alex Rickabaugh.
And we are
the Angular mobile team.
Hold on. Wait for it.
Wait for it.
Whoa. Do you see it? Whoa. All right. Thank you, Roddy.
All right. So we know we're the last talk of the day. It's been a long day. We're all that's standing between you and food.
So we've got 2 hours of awesome content to show you.
Yeah. Jeff's going to develop an entire app from scratch. He's not. He doesn't type as fast as Kara, but he's going to try it. So we're actually here to talk to you about building mobile applications with Angular. Whoa, where's it?
Wow, we skipped far ahead.
Yeah, this thing's fast. Okay. So if you're building an app that's intended for mobile devices, you know that that ecosystem can be really challenging to work in. And if you haven't tried it, the way it works is kind of like this. Let's say you want to build the next big mobile app. You've mastered pizza delivery with drones. 5 minutes or it's free. So what you're going to do is you're going to go out and learn Swift programming for iOS apps and all the ecosystem and toolchain there and build your iOS app. And then you'll forget it all. And you'll start over. And you'll go and learn Android and Java and build your Android app. And if you still have energy left over after that, you can invest in building a mobile web app too, because not everyone in the world is on iOS or Android. So if you're a company doing this, you can probably afford to hire some separate developers and build both apps at the same time. But the problem remains you're still duplicating all this effort, and that's a little inefficient.
Yeah, and it's bad too because if you're building the same app in multiple places, it's probably going to be a little different. The quality is probably going to be a little bit different depending on the team who builds it and the platform it's built on. And it's also just not going to feel the same, and there's all this communication overhead with trying to make the apps consistent. And also it's expensive to have a lot of people building different versions of apps. And if you're a solo person or a small company, that might come down to a choice of you just choosing to support one platform instead of supporting all platforms that your potential users are using. So these are some obvious problems with the typical model of build the same app natively on different platforms. And we've heard some good solutions with NativeScript and other tools today. And those are great solutions too. But let's look at the web. Like, the web is good at solving these problems. The web is a platform that works everywhere, but it has some challenges that we'll talk about later. So aside from the web solving some of these technical challenges, let's look at some of the things the web does really well at in terms of business value. One is that it has a lot more reach. Or it has more reach depending on your strategy. It's searchable, so web apps are automatically searchable, presuming you don't do some bad things to make them not searchable. And they're shareable, so web apps tend to have links to content that stay the same, so that you go to a link, you're going to get the same content you already saw. So that makes it easy to share on Twitter and Facebook, and I'll see a link and I'll be able to easily go to it and see the thing you shared and do something about it. And that comes to the last part, which is they're low friction. If I click a link, it's there. I can choose what to do about it. I don't have to install an app just to see some piece of content that you wanted to share. So with the web having these nice benefits of automatic cross-platform support and reach, why isn't it the default just to build everything as a web app that works everywhere?
So yeah, you might imagine this has actually been tried, and Facebook is a great example. Their first mobile app was an HTML5 based application, but they never really got it to work right. Mark Zuckerberg even came out and said that they just couldn't get it to match the capabilities of a native platform. So why did Facebook come to this conclusion? What makes the native experience so much better that it's worth duplicating all this effort for each platform to build individual native apps? As it turns out, there's some things about native applications which really shine.
So one, if you ask a team who's built apps across different platforms and you ask, why did you choose native? Probably the first thing you'll hear is the performance of native. And it's true, if you click an icon of a native app, you'll probably see something show up right away that at least you know the app is there, even if it's still loading data. And also scrolling around, it's easier to get high frame rates because of the default hardware acceleration of a lot of the components. And then there's re-engagement. You've got push notifications on the app. so you can know when you need to act on something, when you've got a new favorite on your tweet, or also just having it on the home screen so you can open it right back up and get into the app without opening your browser, waiting for it to load, navigating to a screen. And finally, there's API access. Sometimes an app just needs APIs that aren't available on web. Like historically, it's been camera or audio or Bluetooth and storage. And though most of these apps these APIs are making their way into the web platform, there's still some that you just need and you've got to go native for.
Yeah, so given all of those benefits that Jeff talked about with native applications, it's safe to say that Facebook made the right call in committing to native development back in 2013. But I just want to put that in context for a bit. When Mark was on stage talking about how HTML5 apps didn't work for them, Angular 1.2 had just entered its release candidate. And that was a long time ago. Obviously, the web's changed a lot since then. Hopefully, none of you are still using 1.2.
Is anyone still on 1.2 of Angular? Yeah, it's the best one.
Yeah.
Don't upgrade. So we bought onto this new idea that started with the Chrome team called Progressive Web Apps. And what Progressive Web Apps are, we'll go into a little bit more, but essentially it's best practices and techniques based on emerging web standards that have already been implemented in some browsers. The basic idea is you take normal web apps, you make them more powerful by adding new ideas to them, using new platform APIs in different ways, and they can work on any platform but be better on platforms the more they take advantage of the new techniques and APIs in the web platform. So it started with Chrome, but other browsers are on board, which we'll look at later in the slides. So when we say progressive web apps, it's still kind of, it means different things to different people. And when we talk about it today, the things we're going to focus on are these four aspects of it, or three aspects really. The instant loading idea, where you open an app and it feels instant. It feels like the app is living on your device and not something that is being fetched over HTTP. And two, it should work offline or with bad network. You should be able to use some of the app, even if not the whole thing, without needing an internet connection. It should be installable to your home screen so that you can access it just like a native app and have splash screens and full screen just like a native app. And it should be able to send you notifications when there's content that you should see.
So we on the mobile team really believe in what Chrome and the other browsers think, that these are going to be the future of the web. And we think Angular is going to be a great platform for building them. But there was only one real way to find out if that was true. And that was to go ahead and actually make one of these apps. So that's what we did. This is issue 0. Issue 0 is our GitHub issue triaging application. We wanted to do something that was beyond to-do MVC, an actual real application that we would use ourselves and would solve a problem for us. So issue 0 allows rapid triaging of GitHub issues by swiping left or right on them. You can think of it as like Tinder for GitHub issues.
So here's how it works. I've selected a repository in the application, and then I can see issues, and I can swipe to the left to close the issue, and swipe to the right if I wanted to triage the issue, like add a comment to it, like this is legit, add some labels to it, and say, okay, this is a real issue we should deal with at some point, but right now I'm just processing issues. We consider it a good progressive web app, a good start. We've started incorporating some of the ideas we've talked about. And it's built with the hot new Angular tools like Angular 2, obviously, Angular CLI, NGRX, Angular Fire 2, and Firebase. Yeah, Hans, thank you for Angular CLI. RxJS, Ben Lesh, thank you, if you're here somewhere. And NGRX, which is our reactive libraries for data store management. So let's look a little bit more closely on the progressive web app characteristics of issue 0. One is that it loads instantly, and we'll show you how we do this with a technique called app shell. And two, it will work offline. It will load basic functionality, static assets, and some data without an internet connection. And third, it's installable using a new API in the web platform called Web App Manifest. So one of the most important features of progressive web apps, or a technique that's valuable, is called app shell. And this gives the perception that an app is loaded instantly, even if it still needs to do more work to fetch its assets and bootstrap with the framework. And so when we say app shell, we refer to the static UI surrounding dynamic content in an application, which usually consists of a toolbar, some kind of navigation, a side nav maybe. In Angular 2, you could think of it as everything outside the router outlet component in your root component, so the things that are there for all views in your application. So we want to take this root component, everything outside of router outlet, and inline it into our index HTML that's returned from our server when anyone makes a request to one of the URLs in our application. So the goal is to take all this component, render it, inline it in my index HTML so it can be rendered without needing any follow-up network requests, so that the user can immediately see that the app is there and it's doing something before Angular or anything else is loaded and bootstrapped.
So let's take a look at what this actually looks like in issue 0. So this is our index.html page. On the right, you can see it rendered on the phone. We just have a simple title bar and this beautiful material loading indicator. On the left, you can see the actual bytes sent from the server. And what I want you to notice is it's only plain HTML and style sheets. This renders entirely outside of Angular before it downloads. And it can be sent to the mobile device within the first few kilobytes of data for a page, which gives you a very fast first paint over a good 3G connection. But this seems kind of annoying, right? Like, we have this static copy of our application, and then we have our actual Angular application, and we have to keep the two in sync every time we change something. It's just a huge pain. So we don't actually do that.
Yeah, so we actually are using Angular Universal, which you probably heard about earlier today from Jeff Wepley and Patrick. So Universal, it gives us the basic functionality of pre-generating our app shell component. So they talked a lot about what gets generated on the fly from the server, like with Node, where you can have requests fulfilled dynamically. We're using a part of Universal that will actually let you do static generation of assets at build time. So we can take our index.html, our app root component, and use Universal to generate an app shell component in our index.html that will load when requested. And this all integrates with Angular CLI as well.
So here's an example of this in action. Here we have an MD side nav layout, and we're applying this pre-rendered class to it only when this pre-rendered flag is true. So when we compile this application on the server, it will have that class. When we run it in the browser directly, it won't. So we can actually change the styles depending on whether we're pre-rendering or rendering on the client. While pre-rendering, we also want to show this loading indicator. And then we just accomplish that with a simple ng-if. And of course, since this is for static content only, we're going to use another ng-if to hide the router outlet so we don't pre-render it.
So in our application, and under normal circumstances, on a 3G connection in Chrome with the network emulation, the app will load and have its first time to interactivity, or its first paint, at about 2356 milliseconds. But when we add app shell, we bring that number down to 287 milliseconds when the user starts to see the UI of the application working. So that's about a 10 times improvement over when the user feels that the application is responding and doing some work to fulfill their request.
So being able to paint the application shell in a third of a second is fantastic. But that only works if we can actually reach the server in the first place. As we all know, mobile networks aren't really known for their reliability or exceptional speed. And actually, native applications excel really well here because of their installation model. In a native app, code is downloaded up front and runs entirely on the client. And that has a lot of advantages, but also some disadvantages. App Store update processes are notoriously slow, for example, and that's not good when you want to launch a feature quickly or you have a bug that gets past QA. It can take weeks for an update to roll out completely. With the web, we know, as web developers, we just push code to a server, and all of a sudden our users' browsers are downloading it and fetching it and running it. So what would be great is if we could combine these two models. If we could have the offline capabilities of native with the up-to-date capabilities of the web. And it turns out that's possible with a new API called the service worker. You can think of a service worker as a little bit of JavaScript that runs in the background. It's a little HTTP server that runs on your client's machine. They persist and they can cache content even without a network connection, which allows your applications to work offline. But it's actually more important than that. because it turns out rendering things without a server is even faster.
So before we saw that with the app shell, we bring our first interaction time down to 287 milliseconds on a good 3G network. But with service worker and app shell together, on next load of the application, we can see 128 millisecond time before they see something loading. And even the app loading the rest of the way and bootstrapping after that is much faster if its assets are already in the service worker, able to be served from the cache. So we have minimal JavaScript execution here. It doesn't need to wait for Angular, and it doesn't need to parse the app to show this app shell and to use the cache from service worker. And so, like Alex said, this has the performance of native, but also the benefits of deployment that you get with the web, that you don't have to go through the high friction process of updating your app if you need to push something new or push a fix to a critical issue within the app. So we talked a little bit about offline with service workers. Service workers have even more features that we could talk about at another time, but one important thing that we're working on now is adding push notification support with service workers, which browsers are also implementing, so that you can have the same kind of push notification experience you would have on native with the web and be brought back into the application to interact with whatever data was sent with that push notification. So the last thing we're going to talk about is how our app is installable. And we'll talk about a new platform API called Web App Manifest.
Yes, the web platform has this standard called the Web App Manifest that allows you to specify metadata about an application. And in Chrome, you may see this. You can go in and say, add to home screen. Or even now, the browser will automatically prompt you if the app meets certain criteria. Would you like to add this to your home screen? So here, this is my actual phone. I have 6 applications here. 5 of them are actual native applications installed on the device. And there's also issue 0, which is this web app. And what I really like about this screenshot is you can't actually tell. If you open it up, here it's rendering. There's no browser location bar. There's no back button here. We're rendering without the browser Chrome. And you can scroll through the issues. It's 60 frames per second scrolling. It feels like a native application.
So to make this happen is actually pretty simple. We just have to include this JSON-based manifest in our project. And it just has some data about our app so the browsers know how to install it to the home screen. So we have our name, issue 0. We give it some icons of different sizes, our start URL, and then we tell it how to display it. Should it have a browser Chrome or should it be full screen? And then what should its orientation be? Portrait, landscape, both. In our case, we just want portrait because it's a lot of lists of issues. I don't think it would work well sideways. So you might say, okay, that sounds cool, I'm ready to jump in, but how's the support for service worker and these features? And the good news is on Android, Chrome, Firefox, and Opera all have some support for all these features. They support the installable apps, and they all have some service worker implemented, and they continue adding to the features that are supported in service worker. On Safari, there's good signs that they're starting to think about service worker implementation, and we're hopeful that soon we'll see some progress there. And I'm not sure about Web App Manifest. In our docs, we have some guides on ideas to get some of basic offline experience with Safari, and we'll keep those updated as the browsers evolve. So in building the app, we wanted to we were figuring out how some good best practices to do these things like app shell and service worker. And so in the process, we didn't just have these hard-coded in our application. We actually built them as general purpose tools, which we've released as Angular Mobile Toolkit on mobile.angular.io. And this will lead you to our GitHub repository that has some guides on how you can use these yourself with Angular CLI to easily accomplish app shell and service worker support in your app, and also to make them installable. So it's called Angular Mobile Toolkit. We've got a little bit of an alpha version right now. The tools are across a few GitHub repositories, including Universal and our github.com/angular/mobile toolkit. So we're excited to see get some more people starting to get on board and hopefully contribute by either using it or contributing code or telling us that you hate it and why you hate it and how we can make it better. And yeah, so we're excited to get that out there.
Yeah. So we're not actually quite on the RC just yet. We still have a couple dependencies that need to be upgraded, and we're helping them get switched over. And then we can flip that switch ourselves. So you can look for that sometime next week. So that's a little, you've heard a lot about what we can do now. And I'd like to just take a moment to talk about what our plans are for the next few months. So we added this nice new -- mobile flag to the Angular CLI. So you can say ng-new-mobile. Actually, I shouldn't say we did. Hans did it. Thank you very much, Hans. So right now, what this does is gives you a web app manifest. So your applications can be installed to the home screen, just basic boilerplate generation. What we want to do is enable generation of that app shell, so you get all the power of universal and these really fast first paint times. And we want to configure the service worker for you. So you'll just ng-new-mobile, and you'll get a project that has application shell and service worker and works offline. And it's a full progressive web app from the moment you start working on it. And our more long-term plans are to do things like push notifications and background sync.
And Hans said this will all be ready by the end of the week, if I'm not mistaken. Yep, so Hans up here, he'll have it ready.
Calm down.
Okay. So if you want to look at the code for this app, it's at this repository, but don't judge it too harshly. I threw most of it together in the past week, and I'm really insecure about the code. So
and Jeff's pretty self-conscious about it.
Just look at the tooling. Don't look at the actual code in the application. And if it doesn't work, that's a feature.
So do you want to do your hour and a half of live coding?
Oh yeah, I've got an hour of live coding I want to get out of the way before we do dinner now. So I'm just kidding. That's actually the end of our talk.
Thank you very much.
Thanks.